class, and welcome to Math Minutes video lesson number 31. We're going to learn about linear inequalities on a number line. So if you will turn to page 1 in your Math Minutes notebook for semester 2, beginning on page 1, we have lesson 31. And here we go. Linear inequalities on a number line. Before we look at linear inequalities, we first need to understand the difference between expressions, equations, and inequalities. An expression is a statement that contains constants, variables, and operations. And what do those mean? Constants are your numerals like 7, 12, 35, etc. Variables are indicated by letters like X, Y, A, C, etc. And algebraic operations are simply your addition, multiplication, subtraction, and division. So it's a combination of these three things. So an expression can look like this. I can have 2x plus 3. I have a constant, a variable, an operation, and another constant. Here's another example. 4x plus 7 times y minus 2. What do we have? This is a constant. The x is a variable. We have an operation of addition. We have another constant, 7. We have another variable, which is y. Another operation, this time it's subtraction, and another constant. We also have the operation of multiplication because this is in parentheses. That 7 is going to be multiplied to the y and the negative 2. So this is an expression. If you turn to page 2, we're just going to take it to the next step and see what an equation is. An equation has all the elements of an expression, but also contains an equal sign. So think equation, equal. We can make the example from the previous page into an equation by adding an equal sign. So here we have our same 4x plus 7 times y minus 2. Here's the expression, but now we've made it an equation by adding an equal sign and a constant that it equals 15. Moving on to inequalities. An inequality has all the elements of an expression, also like an equation, but it also contains an inequality sign. Inequality sign. And that's these here, where this is less than, this is greater than or equal to, less than or equal to, and greater than. If you want to make some notes on that, less than, I've got a fat marker here. Greater or equal to, this one means less than or equal to, and this one here means greater than. So again, looking at our same example of 4x plus 7 times y minus 2, again, here's our expression, but instead of an equal sign, we have an inequality. And the answer being 15. So moving on to page 3. Well, how do we graph these things on a number line? Well, here we just went over this, but understanding the difference between greater than and greater than or equal to. What this means when you're graphing the inequality on a number line is that you're going to have an open circle or a closed circle. An open circle will look like this if it's greater than or less than, but the closed or filled in circle means it's including the equals. So a closed circle is going to be a solid dot like that. For example, the graph of the following inequality would have an open circle and include all numbers greater than 2. It's an open circle on 2. It's open because it doesn't have the equal sign underneath it. It's just greater than. So we circle 2 because that's our constant. And if x is greater, that means if I were to substitute in the number 3, is 3 greater than 2? Yes. Is 4 greater than 2? Yes. What about something here like 4 1/4? Is that greater than 2? Yes. Basically, any number I pick on the number line up to infinity is going to be this solution. That's why everything greater than that is going to be included on the number line, but not the actual number 2. If we had an greater than or equal to sign, that means it's going to include the number 2 and we would fill it in. Okay, so this will make some more sense as we practice. So turn to the next page, 4, and we're going to practice graphing linear inequalities. So let's start with something like this. X is greater than 0. Well, let's first find 0 and put a circle there. Is it going to be an open circle or filled in? It's going to be open. And what's greater than 0? Our number line always increases moving to the right. So this is a 1, this is 2, this is -1, this is -2. Which side is greater than 0? It's all of the numbers on that side. What would the difference be if I did x is greater than or equal to 0? Well, let's find 0. It's greater than or equal to, so if I have that little line there, that means I have to have a closed circle, and still it's going to be everything that's bigger. Let's try another example. Let's make x less than 2. Well, let's find our constant of 2. Well, if this is 0, this is 1, this is 2, so here I'm going to put my circle at 2. I found my constant. I'm going to decide, am I going to keep it open or filled in? Well, I'm going to keep it open because it's just less than. And which side am I going to draw my line? Well, which numbers are less than? If x is less than 2, that means all my values to the left are going to be included. So if I were to test the number 1 and say instead of x and I substitute in a 1, is 1 less than 2? Yeah. What about if I put in 0? Is 0 less than 2? Yeah. That's why my arrow is going to the left. Okay, let's try another one. How about x is greater than or equal to -1? Okay, let's first find where -1 is on the number line. If this is 0, -1 is to the left. So let's find that by putting a circle there. Now let's determine, am I going to keep it open or am I going to fill it in? It has the equal sign here. That means I'm going to fill it in. If x is greater than that, which side am I going to fill in? Well, to the left is -2, but to the right is 0. Well, we know that numbers increase to the right on the number line. We know that 0 is bigger than -1. So that means everything on this side is going to be shaded. And let's try one more. How about if we had x is less than -1? What's the first thing that we're going to do? Let's locate our constant. -1. Let's put a circle there. Let's decide, am I going to keep it open or am I going to fill it in? I'm going to keep it open because it's less than. And which way am I going to shade? I can test. One way to do it is, let's test 0. Is 0 less than -1? No. That means nothing on this side is going to be true, but everything on the other side will be true. So it's going to look like that when x is less than -1. So I hope that gives a good introduction to graphing inequalities on a number line. Be sure and fill out your notebooks while you watch these lessons and bring your notebooks to class, and good luck.